Hello everyone, very good evening and welcome to Prep Funda. This is Sanjay Rathi. How are you guys? Now today's topic is very good evening. Network theory, steady state analysis of sinusoidal signal part 1. So we have learned about what complex power, power factor and complex number, what is the rectangular form, what is the polar form, okay, and what are the uses of this and how to convert the time domain to what frequency domain, okay. Yes, please. So now this is the case. So this is a steady state analysis of sinusoidal signal part 1 and this is my introduction, myself Sanjay Rathi. Now first of all, you have to get the command over the basics. So first we have covered what KCL, KVL, mesh analysis, nodal analysis, Ohm's law, series connection, parallel connection of resistor, inductor, capacitor, voltage division rule, current division rule. Then we have learned about the theorems. Thevenin's theorem, Norton's theorem, superposition theorem, maximum power transfer theorem. We have dealt with what? DC signals. Now we are going to dealing with AC signals. So what is the AC signal and steady state analysis of AC signal? And that's why we have learned complex power, power factor, reactive power, effective power, what is the P, what is Q, right? Leading power factor, lagging power factor. Okay, now that is my Telegram channel. You can join, Electronics by Sanjay Rathi, and if you have installed the app, okay, otherwise you can install the app. Now guys, in the previous class we have discussed the complex power. Quick revision. Complex power, P plus JQ. Okay, so P plus JQ, where P will give what? Effective power. Effective power or average power, and Q will give the reactive power. This is also called active power. Its unit is what? Its unit is volt ampere reactive, and the magnitude of that will give apparent power. Unit is volt ampere. This is the apparent power. So this is the complex power. Already I have discussed the formula, and magnitude will become root over P square plus Q square. Real part is this one, imaginary part is this one, that is called real power or what, active power or effective power. Then reactive power, that is the power factor P by S. Already I have given the P by S will give you the power factor. And now if suppose any impedance is given, guys, any impedance is given Z, X plus JY, right? Any for you have the idea about the impedance X plus JY, then complex power will be given by I RMS square. Remember, you have to find the root mean square value of the current multiplied with Z. It will become I RMS square into X plus JY. And guys, then it will become I RMS square into X plus J I RMS square into Y. Now this is called what? P, and this is called Q. So directly you can find, if you have the idea about the impedance, then real part and imaginary part you will get. Then if you have the RMS value of the current, then you can give the P part and Q, P and Q, guys. So directly you can multiply. And remember, this P or real part will give what? Real power or effective power or average power that is transferred to what? Load. And this is the reactive power. This is the reactive power. So this is the case. V RMS, I RMS, cos of theta V minus theta I, where theta V minus theta I is normally known as theta. Remember, if the imaginary part is 0, if the Q is 0, then load is what? Purely resistive. If the load means this term is 0, imaginary term is 0, means load is what? Purely resistive, and you will get the Q is equal to 0. Then it is a complete effective power, and the power factor will become what? Unity, 1. Voltage and current are in same phase. Always remember, this is a revision, na? New student, please watch the previous lecture. This is the quick revision actually. Now, if the load is purely resistive, means voltage and current are in phase. What is the difference? Theta V minus theta I is equal to what? 0. And therefore, what is the cos of theta V minus theta I? That is called power factor, is equal to 1, unity power factor. So this is the case. If the Q is less than 0, so already I have said, so what is the Q? Negative. If the Q is negative, so already I have given, that is the Z, this term is negative. This term is negative, then Q will become negative. Or this term is negative means load is what? Capacitive. Load is capacitive. For example, if R and C are connected in series, so what is the total impedance? The impedance will become R minus J by omega C. And what is the S will become I RMS square into Z, means this is the R minus J by omega C. From this you will get the real part positive. And what about the imaginary part? Negative. What is the Q? Negative. Q negative. And what is the load? Capacitive load. Or in case of capacitor, always remember, current leads voltage. I leads voltage. Today we will get the idea about this. I leads voltage. And that's why it is called leading circuit. Power factor is leading. That is the conclusion. Q is less than 0 for capacitive loads. This is the leads the power factor or leading power factor. And if the Q greater than 0, for example, in case of RL circuit, what is the load? R plus J omega L. So what is the S? I RMS square into Z. When it is multiplied, it will become I RMS square into R plus J omega L into I RMS square. You can compare what is the P part positive, what is the Q part positive. Both are positive. Load is what? Inductive. Or in case of inductive, current is what? Lagging. Current lags voltage. And that's why it is called lagging power factor. Lagging power factor in case of Q positive. Leading power factor and lagging power factor. Or if the Q is 0, means what? Imaginary part is 0. Means it is a purely resistive load. Voltage and current are in same phase. In a theory, if there is any doubt, and today we will discuss what RC circuit, RL circuit, what is the phasor diagram, what is the relation between the current and voltage. You will get the idea. If there is any problem in a complex power, you can ask. In a previous class, I have given the idea about what is the complex power and so on. We will calculate it. For few questions, we will calculate first of all. Any doubt? Read it carefully. If you have any doubt, then please ask. Kamini, other students, any doubt? Sir, please repeat. एक minute, your comments are not visible to me. Give me 1 minute. Yes, please. What is the doubt? Okay, that is case less than 0. Try to understand case Q is less than 0 means what? If suppose the load is capacitive. So load is capacitive means what is the impedance here? R minus j omega c. Watch this. If the R minus j omega c, so write as I RMS square R minus j omega c. So this is the real part, this is the imaginary part. What about the imaginary part? Negative. So Q is what? Negative. When we are comparing with this, suppose it is a, when we are comparing this equation and that equation, you will get the P is equal to what? I RMS square into R. What is the Q is equal to? Minus I RMS square by omega c. So what is the Q? Q is negative. If the Q is negative, means it is a capacitive load. Or in case of capacitive, we will learn, in case of capacitive, I leads what voltage? I leads voltage. I leads voltage, and that's what is called leading power factor. Yes, please. No. Who told you that the real power is also called? No. Instantaneous power is different thing. Instantaneous power means Vt into It. That is the function of time at particular instant. It is not an instantaneous power. Average power, real power, average power, effective power. Is it clear? Suppose we are taking the 2 hours class, so at instant my energy is very high, but after 2 hours, after 15 minutes, my energy will be low. Again my energy will be high. So on an average, within 2 hours, what is my level of energy? That is called what? Level of power. That is called what? Average power. Are you getting my point? So we are finding the average power. Instantaneous power means at particular instant. For example, exactly at 4:30, what is the power? but we have to calculate the power from 4:30 to what 6:30 within 2 hours. That is called average power. Okay, we have to find the average power, not the instantaneous power. Real power is not instantaneous power. Normally it is known as what? Average power or effective power, useful power. Right. Then, so this is the case. Now we will solve question and I will give you the idea how the current will lead or lag. I have given you the formula for the power factor, leading and lagging. Then impedance. So this is what impedance, remember. As a complex quantity, the impedance in a rectangular form is given as R plus jx. R is the real, is the resistance, and X is the, if X is positive, impedance is inductive. Inductive means R plus j omega L, means it is inductor, and that's why the cube imaginary part is what? Positive. The load is capacitive, then it will become what? Z is equal to R minus j by omega c. If the imaginary part is negative, means it is a load is what? Capacitive. Load is capacitive. This is called impedance. This is called impedance, R plus jx. Okay, so if this is the imaginary part is positive, then inductive load. Imaginary part is negative, then it is called capacitive load. Then what is the admittance? Admittance means reciprocal of what? Impedance. Admittance is given by, for example, Z is given by R plus jx. R is called resistance, right? X is called reactance. What is the R? Resistance. What is X? Reactance. That is the name. Imaginary part is called reactance because of inductor or capacitor or both. Okay. Then what is the admittance? G plus JB. G plus JB. So here G is known as conductance. Real part is known as conductance. And B is called susceptance. Susceptance. B is called susceptance. This is written here. Okay. Or this is called conductance. So normally students are just, I said, for example, I am giving Z is equal to what? R plus JB. R plus JX. Just, and Y is given, Y is equal to 1 by Z, that is equal to what? G plus JB. The students are saying that here G is equal to 1 by R. That is wrong. Not G is not 1 by R. This is wrong. This is wrong. We have to find the 1 by Z, then real part is Z and imaginary part is what? B. Remember. So we have to find the 1 by Z. Then real part is G, imaginary part is what? V. For example, G plus JB. What is the real and imaginary part? What is the Y? 1 by Z. What is the 1 by Z? 1 by R plus JX. It is multiplied by R minus JX upon R minus JX. Then it will become R minus JX, that is the real and imaginary, upon R square plus X square. So what is the real part? R upon R square plus X square. What is the imaginary part? Jx upon R square plus X square. Now you can compare with the G plus JB. So what is the G? 1 by R? No. What is the G? What is the G here? Real part. R upon R square plus X square. Always remember. What is the B? Susceptance. X upon R square plus X square. So normally students are, what they are doing? G is equal to 1 by R. If it is purely resistive, try to understand. If it is purely resistive, then only there is G and G will become 1 by R. For example, it is purely resistive. Yes, then it can be represented as G. And what is the G? 1 by R. But in this case, it has the two part, real as well as what? Imaginary part. So you have to find the reciprocal of that. This is possible in case of purely resistive. Purely resistive means that is x is equal to 0. For example, you are putting the x is equal to 0, g is equal to 1 by r. You will get the idea, and the b will become 0. Okay. So students are doing the silly mistake. They are directly saying that g is equal to what? 1 by r. This is wrong. Wrong. So always remember how to find the admittance. Easy. What is the impedance? Real part and imaginary part. Real part is called resistance. Imaginary part is called reactance. Okay, this is written here, resistance and reactance. Then real part is called conductance. Imaginary part is called susceptance. Y is equal to 1 by z. You have to find the real part and imaginary part. Right. Now it is time to solve some questions. First, guys, with this question you will get the idea about the instantaneous power, average power and effective power. Okay. Okay, now use your virtual calculator and try to solve this question. Everyone, use your rough copy pen and calculator. If you are watching the recorded lecture, stop the lecture. First of all, solve the question and then go for what? Solution. Then go for solution. Okay. VT 120 cos of 377t plus 45 degree. And IT is equal to 10 cos of 377, that is the omega. Omega is what? 377 here. IT is given, find the instantaneous power. Watch this. What is the word here? Instantaneous power and the average power absorbed by the passive linear network of the figure. Average power is required as well as instantaneous power. Average power is also known as effective power or real power. Now we are going to find both average power and instantaneous power. Now there are two signals. If you want the instantaneous power, so you have to multiply these two signals. So directly you can multiply for instantaneous power. Remember what is the instantaneous power means? This is the VT into IT. Directly you have to multiply these two signals. 120 into 10, that is become 1200 cos of omega t, 377 is the omega, plus 45 cos of omega t plus 10. Already I have solved cos A plus cos A cos B. What is the cos A cos B? Half of cos A plus B plus cos A minus B. You can write PT is equal to half 1200 divided by 2. This is the half cos of A plus B. So A plus B means it will become 2 omega t plus 45 plus 10, that will become 55 plus cos A minus B. What is the A minus B? Omega t cancel. 45 minus 10, it will become 35. 35 cos A minus B. Okay. Now this is what instantaneous power, guys. So what is the instantaneous power? It has the two term 600 cos of 2 omega t plus 55 plus 600 cos of 35. Right. Now what about this term? This depends upon the time. For example, if you want to find at 1 second, put the value 1 second. What is the omega here? 377, and then you can find the value at exactly at 1 second. But remember, if you want to find the power at 1 second, what is the instantaneous power? This is the total power, is the instantaneous power. So suppose if you want to calculate the power at 1 second, just use your calculator. For example, this is the value, and now just I want the power at 1 second. Let the t is equal to 1 second. What is the instantaneous power at this time? So first of all, the PT will become 600 cos of 2 into 377, value of the omega is 377 into 1 plus what? 55 degree. Remember, this is in degree and that is in radian. You have to convert the radian into what? Degree. Radian into degree first of all, because what is the unit of omega? Radian per second. Plus 600 cos of 35 degree. What is the radian to degree? What is the formula radian to degree? 2 into 377. If you want to convert it to degree, 377 into what? 57.3. Already I have given, you can convert it into what? Degree. You have to multiply with the 57.3. That is the 180 by pi. So 2 into 377 into 57.3. Degree is 43204. Degree. What is the plus 55? Plus, this is the value, plus 55. 43259. Four three two five 9.2. Find the cause of that. You will get the 0.512. It is the total value is 0.512. This will become instantaneous power. This value is 0.512 into 600. Plus 600 into cos 35. What is the cos 35? 0.819. And this is the instantaneous power. 0.819 plus 0.512 into 600. 798.69. 798.69. This is called instantaneous power. Are you getting my point? But there is no use of that instantaneous power. At particular instant, that is the amount of the power. At 1 second. At 2 seconds, the power will be different. At 3 seconds, the power will be different. So this is the power exactly at t equal to 1 second. And that power is called instantaneous power. So you can find power at 1 second, 2 second, 3 second, because we have the formula. This is the formula. It is depends upon time. Easy? So why I have solved this question? Because remember, when we are multiplying the omega t, it will give radian. So radian, to convert the radian into what? Degree. So radian to degree you have to convert, otherwise you will get the wrong answer. This is in radian, this is in degree. And the 55 it is in what? Degree. 35 it is in degree. It is already given. This is mentioned here. 45 degree, 10 degree, and so on. Now, average power. What about this term? This term is actually what? Average power. This term is average power. Suppose if you want the average power, then P average, P effective is nothing but VRMS, IRMS, cos theta. Theta is theta V minus theta I. What is the theta V? 45. What is the theta I? 10. That's why it is 35. Therefore, average power is 600. This is nothing but VRMS, IRMS by right into 35, cos 35. So directly you can find the value. Cos of 35 into 600, 491.49. And that is the average power. There is a difference between what instantaneous power and average power. 491.49, this is the average or effective power, and what is the instantaneous power? Instantaneous power was 798.69 watt. There is a difference. I think that both the concepts are clear. Average power. इसलिए देखो, these are the questions from what standard textbook. When we are solving some questions from standard textbook, actually we are getting the idea about what is the instantaneous power, what is the effective power, what is the average power, and that is the use of the formula. In first class I have given you the idea about what instantaneous power and average power. So this is the instantaneous and average power. Any doubt, then you can ask. First slide. Vt into I2, it is given in the question. So 120 plus 10, that is the 1200 by 2, because cos A cos B is equal to half of cos A plus B cos A minus B. Then it will become 600 at t equal to 1 second. That is called instantaneous power. Convert the degree radian into degree, put the value, and then finally this is a plus 10, na? Yes. You can find directly formula. Yes, you can use. If you have the idea about the formula, directly you can find. Objective question, directly you can give the answer for that. No problem. Okay. Yes, निकाल सकते हो ना. This is the formula. This is the formula. Yes, we have the formula. What is the formula for that? VRMS, IRMS, or what was the formula? This is the first one, first term, and then second term. Yes, that is the direct formula. Yes, directly you can use VM. What is the VM? It is given 120, that is 10 divided by 2. You can directly use 120 into 10 divided by 2 cos of 2 into 377 into T plus what is the theta V? Theta V is 45 and 10. This is plus. Okay, plus 120 into 10 divided by 2 cos of 45 minus 10. Finished. Directly you can, this is called, complete power is called instantaneous power, and that is called average power. Okay. Then next, watch this. For the circuit shown in the figure, find the average power supplied by the source and the average power absorbed by the resistor. What is the average power given by the source and what is the average power absorbed by the resistor? That is the question. It is a RC circuit. This is the R and that is the C. So you can find the Z, you can find the I, then you can multiply it, real part and imaginary part. From that you can find, and then I will give you the shortcut also. Then if it is a circuit, RC circuit, first of all, in case of RC circuit, find the Z. What is the Z? R minus J by omega C, because it is a capacitive circuit. That's why it will become 4 minus J2. This is the 4 minus J2. You can find the magnitude of that. 4 square plus 2 square, that is the 16 plus 420 root 20 ohm. Magnitude is root 20 ohm. What is the angle here? Tan inverse of imaginary upon real, and real is imaginary is negative, and that's why overall angle is negative. It will become tan inverse of 2 by 4. Tan inverse of 1 by 2. What is the tan inverse of 1 by 2? From calculator you can find. ना कॉम्प्लेक्स में थोड़ा कैलकुलेशन फास्ट करना ना. tan inverse of 0.5. 26.56. Right, this is the angle. Okay, now this is about the Z. Then if you have the magnitude, and then you can find the current. What is the current here? Current will become V by Z. What is the V? 5 angle of 30 degree divided by. Remember, in a particular numerical they will give whether it is a RMS value or peak value. I am giving it is a peak value. It is a peak value, then you have to find the RMS value from that. So it is a peak value. So current will give you the peak value. What is the Z? Z is magnitude is 20. What is the angle of the Z? 26.56. This is the magnitude and that is the 26.56. From this you can find the I. So what is the I here? Root 20 reciprocal of that into 5. Okay, that is 1.118. Angle, this is 30 minus 26.56. And that angle is what? Negative. Remember, this angle is negative. Because it is a capacitive circuit, negative. It will add 56.56. So current leads the voltage. Because what is the angle of, watch it. What is the angle of the voltage? 30 degree. And what is the angle of the current? 56.56 degree. Means what? Current leads the voltage by 26.56 degree. Here directly you can say current leads voltage by 26.56 degree. You can find the difference between the theta I and theta V. So this is the leading. That's why the capacitive circuit is called leading circuit. Now if you have the value of the I, remember if it is the peak value, this is also a peak value. This is a peak value here. Then what is the power given by that battery? You can multiply, you can find the power here. The average power given by the battery. So what is the power? V into I, because you have the V phasor, I phasor. What is the V? 5 angle of 30 degree. And what is the I phasor? This is the I, 1.118 angle of 56.56. 56.56. But remember, what is the complex power? What is the formula for the complex power? You can't directly find like this. What is the formula for the complex power? VRMS, IRMS, complex conjugate of IRMS. And that's why it will become, what is the VRMS? 5 by root 2 angle of 30 degree. Because it is a peak value, so it is divided by root 2 and angle of 30 degree. What is the IRMS? 1.118 divided by root 2. This is called RMS value and angle. If it is positive, so in a complex conjugate, it will become negative. Minus 56.56. This is the angle. Remember. Now you can multiply S is equal to, this is multiply and root 2 into root 2, it will become 2. So this is 1.118 into 5 divided by 2, 2.795 angle minus 26.56. Add these two and you will get, this is the complex power. Complex power. So what is the real part of that? 2.795. This is the cos of 26.56 minus j sine of, why minus? Because it is a negative sign, minus j sine of 26.56. And now you can multiply 26.56 cos of this 0.894 into 2.795. So you will get the 2.5 here minus j 26.56 sine of this into 2.795. 1.25 nearly equal to. So what is this? S is equal to P plus JQ. Because the circuit is capacitive, that's why we are getting the Q negative. And what is the P? This is called real power or effective power. So what is the real power or effective power? 2.5 watt. So what is the average power delivered by the battery? Average power delivered by the battery is 2.5 watt. Thus it does answer. This is nothing but average power delivered by the battery. 2.5 watt, real part. It is a very, very simple question. 5. Negative, yes. Already I have given a negative value. No. So what is the procedure? First of all, find the Z. Z is R minus J omega C, 4 minus J2. Magnitude will become root 20. Angle will become minus 26.56. Then I will become V by Z. That is a simple. It is in a polar form. V in a polar form, Z in a polar form, I in a polar form. Then I leads voltage by 26.56, and that's why it is called leading circuit. Okay, and then finally, what is the power here? VRMS, IRMS, this is called RMS value, that is called RMS value. Multiply and divide real part and imaginary part. Real part is called what? Average power or effective power. Okay. Now, if you want, directly you can also solve. How? For example, what is the I? I is 1.18, angle of 56.56. Okay. Now, you have, what is the S? I RMS square into what? Z. You can say I RMS square into R minus J by omega C. This is the impedance. And this real part, what is the real part here? Because it is equal to P plus JQ. So already I have given what is the real part. I RMS square into what? R only. Directly you can multiply. So what is the RMS value of this? 1.118 divided by root 2, the whole square. And what is the value of the R here? 4 ohm. Please get the, what is the answer here? Tell me. So what is the square of 1.118? Into 4 divided by 2. You are getting the 2.5. Yes. P part is 2.5 watt. So this is the average power consumed by the load. So what is the average power delivered by the source is nothing but average power consumed by the load. So average power consumed by the load. Finished. तो जितना भी आपने एवरेज पावर बैटरी ने दिया है that what imaginary part of the angle always come in like why it is a capacitive, that's why we are getting. Suppose the inductor is inductive, then suppose there is inductor, then imaginary part is positive or negative. It is a capacitive circuit and that's why we are getting the negative value. We have solved only one question. Okay. Because it is a capacitive and that's why we are getting the negative value of angle. Then it will become positive, current leads the voltage. For example, in this question, tell me what is the impedance? In the circuit of figure, calculate the average power absorbed by the resistor and inductor and find the average power supplied by the voltage source. Inductor will not absorb the power, it will store the energy and so on. That's why the average power absorbed by the inductor is directly, we can say, 0. Now in that case, tell me, what is the impedance? Impedance is positive. Similar method, you can find Z is equal to R plus J omega L. What is the R? 3. What is this one? What is the imaginary part? Positive. So what is the magnitude of Z? 3 square plus 1 square, that is nothing but root 10. And what is the phase of that? Tan inverse of imaginary upon real, positive value. Tan inverse of imaginary upon real, that is the positive value. (18.43) (435). This is the, now you can write the Z as magnitude of Z, angle of that Z. It will become root 10. This is the magnitude, and what is the angle here? 18.435. What is the angle? Positive. Now what is the current here? Current is given by voltage upon Z, that is 160. This is again the peak value, angle 45, upon root 10, angle 18.435. Right? This is the case. I will become 160 divided by root 10. 16 root 10. Angle 45 minus 18.435. 26.565. This time what is the angle of the current is less than what angle of the voltage by 18.435, and that's why we can say current lags voltage. By this angle 18.435. So that angle of Z itself, this is the phi or theta, it is the phase difference between what voltage and current. Directly here theta V minus theta I is nothing but what? Theta Z, phi Z, or this is called theta. So what is the cos factor? What is the power factor? Cos theta. So you can directly get the angle of the Z and it will give you the theta, and you can find the power factor. Power factor directly 18 cos of 18.435. This is called power factor. So reactive load Z is responsible for phase difference between voltage and current. So that is called the resultant current in ampere. Okay. Now if you have the current, this is the peak value. Now how we can say this is the peak value? Because in a Sadiku na, this is a peak value. Actually in a GATE exam they will give you the RMS value. If it is the RMS value, I is in RMS value, no need to calculate the RMS value. But it is the peak value, then it is also a peak value. It should be divided by root 2 to get the RMS value. Now again, what is the average power delivered by the load? You have to multiply it. When we are multiplying, so what is the average power? It is given by S, complex power. Complex conjugate. Then it will become 160 angle of 45 divided by root 2. This is the RMS value, angle 45, into 16 root 10 divided by root 2. Complex conjugate means angle will become negative. 565. Now multiply it. (160) into 16 divided by 2 into root 10. 4047.71. Angle. Add this to 18.435. This is called complex power. So what is the P and what is the Q? P plus JQ. How you can find? 4047.71 into cos of 18.435. It will give you the real part, and 4047.71 into sine of, it will give you the reactive power. This is the effective power and that is the reactive power. Now you can find the value. Finished. .9486 into to P3839. Just I am going to find the P. 3839.99 watt. You can write 383. This is the become 40 watt. This is the value of effective power or average power, guys. Average power. So what is the average power delivered to inductor? 0. How we can say? This is the average power delivered by the source, and what is the average power consumed by the load? The average power consumed by the load, you can find average power consumed by the load, you can find I RMS square into R. So what is the I? 16 root 10 upon root 2. This is the IRMS square of that into R 3. So what is this? 16 to 56. What is the square of 10? Root 10, 10. What is the square of that? 2 into 3. So it will become 256 into 10 into 3, or you can multiply and you can find. (3840). We are getting the same answer, yes or no? We are getting the same answer. What is the average power delivered by the load and source, and what is the average power consumed by the resistor? 3840 watt. What is the average power consumed by the inductor? 0. Inductor will store the energy, it will not absorb the load. Array current, where is the negative? Where is the negative? Tell me. What is the angle of the Z? What is the angle of Z? Positive, na? Angle of Z is positive. Inductive means angle of Z is positive. This is the positive angle. Where is the negative angle? But it is in denominator, then we have to subtract, and that's why what? Current lags the voltage by this angle. Okay. When we are calculating the complex power, we have to find what? Complex conjugate of IRMS. When we are taking the complex conjugate, if the angle is negative, then it will become positive. If it is positive, then it will become negative, and so on. Where I have taken the negative? Tell me, in which equation you have the doubt? In which equation you have doubt? In equation number 1, in equation number 2, in equation number 3, in equation number 4, in which equation you have doubt? Equation number 5, 6, 7, 8, 9, 10, 11, 12. This is called complex power. 13, 14, 16, 15, 16, 17. And that is the answer. This is called average power P. And directly, if you have the value of IRMS multiplied with the R, you will get the average power. This is a very, very easy shortcut. In GATE, we are using this. V average is IRMS into R. And remember, we have taken it as the peak value. But in a particular numerical, if nothing is mentioned, this is the RMS value. No need to divide it by what? Root 2. Power calculation clear with RC circuit and RL circuit. अच्छा नेगेटिव बोले थे एंड देन यू हैव रिटर्न राइट. ओके, हो जाता है. Slip of tongue. That is the value. Now it is clear, na? Okay. Series connected load draws a current. This one. When the applied voltage is this one. Find the apparent power and the power factor of the load. Determine the element values that form the series connected load. You have to find the element values, whether it is an inductor or capacitor or inductor or resistor and so on. So a series connected load draws a current 4 cos of 100 pi t when the applied voltage is 120 cos of 100 pi t 20 volt. Can you write in a phasor term? I. 4, it is the peak value, and what is the angle? 10. So you can write 10. What is the omega here? 100 pi radian per second. Omega is your 100 pi radian per second. Then what is the V phasor? What is the value? 120. Angle 20 degree. Guys, remember, V leads the I. V leads I or I lags V by 10 degree by theta V minus theta I. What is the theta V minus theta I? 20 minus 10. 10 degree. V lead the I by 10 degree or I lags by. So what is the, tell me, what is the inductive circuit or capacitive circuit? Current lags behind the voltage by 10 degree. Inductive circuit or what? Capacitive circuit. Okay, tell me. Inductive circuit or capacitive circuit? Give me 1 minute. बोलिए जरा. No. Just I am giving you a shortcut. Array, one by one. First of all, solve it. Then I am going to give you the shortcut. Then we will solve previous year questions. Automatically you will get the idea. Don't worry about that. When we will solve previous year question, then shortcut we are going to use. Or we have solved first basic. So if suppose from first question we are doing shortcuts, we are using the shortcuts, then it will create problem. Directly you can use the shortcut. In this question you can directly use the shortcut. So what is the phase difference between voltage and current? 10 degree. So what is the power factor? Power factor is nothing but cos theta. Theta is theta v minus theta I. So it will become cos 10. Cos of 10 degree, that will become power factor. Answer. What is the power factor? Yes, it is an inductive circuit. .984 or .985. That is the answer. Power factor. 1 mark question. What is the power factor here? Now it is an inductive circuit. What is asked? What is the apparent power? Apparent power is Vrms into Irms. The apparent power you can directly find Vrms into what? Irms. So what is the Vrms? Apparent power means magnitude of S. Vrms into Irms. So what is the Vrms here? 4 by root 2, 120 by root 2 into 4 by root 2. 4 by root 2. So it will become 120 into 4 divided by 2. 240 volt ampere. This is the apparent power. This is the apparent power. Finished. Question finished. Now if it is asked, what is the average power? The average power is nothing but Vrms Irms cos theta. What is the Vrms Irms? This is the apparent power 240. What is the cos theta? We have calculated cos theta 0.985. That will give you the average power. So in number of numericals you have to calculate the average power. 240 into 0.985. 236.4 watt. Direct we are using the formula. What is the reactive power? Vrms Irms into sine of theta. Guys, what is the Vrms Irms? It is the 240. Vrms Irms is the 240. Check my calculation also. Into sine of theta. So what is the theta power factor? Theta is what? 10. So what is the sine 10? 0.173. .67. It is called reactive power. Volt ampere reactive. So what is asked here? Question. This is the. Now if it is an inductive circuit, try to understand. Now this is called what? This is the P. This is P, average power, and this is what? Q. Now we have the value of P and what? Q. And that's why you can write. That's why you can write S is equal to P plus JQ. Q is positive, means inductive. What is the P? 236.4. What is the Q? 41.67. Now you have said it is a RL circuit, inductive circuit, RL circuit. Can we find the value of L and R? Yes, we can find, because what is the complex power? This is nothing but I RMS square into what? Z. What is the Z? R plus J omega L. Now you can compare I RMS square R is equal to a 236.4, that is nothing but P. So what is the value of the R? 236.4 upon I RMS square. I RMS square. So this is the, what is the I RMS square? That is the 4 by root 2 square. Four by root 2 square. You can find the value of R register. बताइए जरा आंसर कितना आ रहा है? So this will become 16 by 2 means 8. $29.55, around 30 ohm. Check my calculation. Or what is this? I RMS square into omega into L. I RMS square into omega into L is equal to what? 41.67. So what is the value of the inductor? 41.67 upon omega into I RMS square. 41.67, what is the omega? 100 pi into I RMS square. This is the I RMS square. This is the 4 by root 2 square. You will get the value of what? Inductor. मैंने एक क्वेश्चन पूरा कंप्लीट सॉल्व करने दो. You will get the idea. .0165 हेनरी और 16.58 मिली हेनरी. 16.58 milli Henry. Very, very low value of inductor. And that's why we are getting very high value of what? Power factor. That is the case. So watch it carefully. What I have done, just nothing, diagram is given, nothing, current and voltage is given. So you can find the current 4 angle 10, voltage 120 angle of 20 degree, and then I lags the V by that theta V minus theta I. Theta V is 20 degree and theta I is 10 degree. So voltage leads the current or current lags the voltage, and that's why it is an inductive circuit. Power factor is 0.985. So any doubt in any equation, then yes, you can ask. In first slide, any doubt? Equation number 1, 2, 3, 4. This is called 5, this is 6, and that is the value 7. So this is called how we can find the power factor. This is the first question. What is the power factor? So directly, quickly, 20 minus 10 cos of that. 20 minus 10 cos of 10. So directly you can find power factor. Then apparent power means VRMS into IRMS. The apparent power you can find VRMS, IRMS. This is the 240 volt ampere. Now average power is given by Vrms Irms cos theta. The cos theta is 0.985. This is nothing but P. Reactive power is Q, Vrms Irms sin theta. You can find. Now this is the 7, this is the 8, 9, 10, 11. This is 12. To find the average power directly, you can multiply with the power factor cos theta. 10, 18. This is 19. Then this is called complex power. Once you have the value of P, once you have the value of Q, you have the access to what? Complex power. This is called complex power. Complex power. Then complex power is nothing but I RMS square into R plus j omega L. So from this you can find the value of R and value of L. Because we have the value of P and we have the value of Q. Then you can find. If there is any other method? Is it clear, everyone? Up to this point, any doubt, then please tell me. So this is the power 21. We are just comparing. We are finding the value of R. This is the P. We are equating it and just find the value of R. And then I RMS square omega L, that is nothing but Q. And we are comparing. We are getting the value of inductor, very, very low value. Tell me up to this point any doubt, then yes, okay, otherwise. ऑल पॉइंट्स क्लियर, बहुत बढ़िया. नो नेक्स्ट. इजी है ना, कल तो बोल रहे थे आप फॉर्मूला याद करने में सर प्रॉब्लम है. यही तो है, डायरेक्ट डायरेक्ट स्ट्रेट फॉरवर्ड. If there is a calculation mistake, then please inform me. Otherwise, concept is okay. Now I will give you the idea about the phasor diagram of what inductive circuit and capacitive circuit, so that we can solve more question. Then for example, RC circuit. First we will deal with RL circuit. RL circuit means in a particular we have R and we have inductor. R, and let this is the voltage. Okay, always remember in a series, sir. No, for this week, because we have some work for it, we are working on it. Actually, commonly don't worry about the time. We are here just to for what mainly we want communication. एक दूसरे के बीच में ना communication होते रहना जरूरी है. आप interact करते रहो, assignment पूरा करते रहो, right? और अभी क्या है ना, धीरे धीरे अभी गेट 2025 के लिए लोगों को इंटरेस्ट आ रहा है, नहीं आ रहा है. तो some students are watching only recorded lectures. They are not interested to watch what live lecture. But they have no idea. Because of live session we can maintain our what consistency. Yes or no? तो आप रेगुलर अटेंड कर रहे हो तो रेगुलर आपको समझ आ रहा है. ज्यादातर बच्चे रिकॉर्डेड लेक्चर्स देखना चाहते हैं. रिकॉर्डेड में क्या होता है, आप 1.5 की स्पीड में देखते हो, चीजें समझ में ही नहीं आती. तो प्लीज ट्राई टू सॉल्व विद मी द क्वेश्चंस एंड सो ऑन. दिस वीक इट विल रिमेन, this week or I think next week it will remain the same time 4:30. If there is any change then I will inform you, otherwise almost 4:30. If suppose there is a change then I will inform you on your WhatsApp number. So RL circuit means, always remember guys, current will remain same. For example, this is the current phasor, this is the voltage. So what is the VR? And this is the voltage across the inductor VL. Now, what is the VR? VR is I into R. So VR and I are in same phase. The voltage across the resistor and the current are in phase. R in phase means there is no phase difference between I and VR, voltage across the resistor. Now what is the VL? VL is I into ZL. I into ZL. Now what is the I? I phasor, and ZL is what? J omega L. What is the angle of that? 90 degree. VL will become I into omega L, angle of 90 degree. Means what about the voltage? Voltage leads the current by 90 degree. VL leads I by 90 degree, or we can say I lags the VL by 90 degree. That is because it has the J omega L. So this is the reason. So can we draw the diagram, phasor diagram? Yes, we can draw. Watch it carefully. Phasor diagram. Now that this is I. That this is I. On x-axis I am taking the I. So what about the VR? VR, it is in the same phase. This is the VR in the same phase. And what about the VL? VL lead the I by 90 degree. VL lead the I by 90 degree. That is the case. So this is the VL, this is the VR. So where is the resultant? So resultant you can find this one. And that is the resultant, guys. So this is the VL, this is the VR. So what is the resultant? So normally when we are using the KVL, so what we are doing? We are adding, but here that is a phasor sum. What is the phasor sum? Total V or resultant V is given by a real part. What is the real part? VR plus what? J times of what? VL, because it is a 90 degree leading, and that's why this is the VR plus J times of VL. This is the imaginary part. J times of VL. So what is the magnitude of V? Magnitude of V will become root over VR square plus VL square. VR square plus VL square. Always remember. Suppose just I am giving you the question. If any circuit is given, This is the applied voltage V. The voltage across this VR is given as 3. Voltage across the VL is given as 4. So tell me what is the value of V? What is the value of V under steady state? So normally students are doing what? Sir, the value of V is 3 plus 4, that is the 7. Direct KVL. Directly they are applying the KVL, Kirchhoff's voltage law. But KVL is applicable. Kirchhoff's voltage law is applicable. But what is the phasor sum? So what is the phasor sum? That is the phasor sum. VR plus JVL, and that's why the answer for this question is not 7. Answer for this question is root over 3 square plus 4 square, that is nothing but 5. Phasor sum is 5 volt is the answer for this question, not 7 volt. This is wrong. Okay. So always remember, in RL circuit, current and voltage across the resistor are in same phase. Current and voltage across the inductor has 90 degree. VL will lead the 90 degree. And finally, that is the resultant. Watch this. This is the current and this is the voltage. So current lags the voltage, applied voltage. This V is nothing but applied voltage and current. So this is the theta. So current lags V by theta. And watch this. This is the VL. This is the VR. So what is the theta? Tan theta is equal to VL by VR. Or you can say theta is equal to tan inverse of VL by VR. And what is the VL? Tan inverse of VL, magnitude of VL, magnitude of VR. So what is the VL? I times of omega L. And what is the VR? I times of R. I cancel. And that's why this will become tan inverse of omega L by R. Tan inverse of omega L by R. That is called phase difference between voltage and current. So directly you can find the phase difference between voltage and current. This is the applied voltage and that is the resultant current. Current lags the voltage by theta degree. You can also find the power factor. If you have the value of the theta, you can directly cos theta will give you the power factor. Cos theta will give you the power factor. Okay, this is the cos theta. The power factor is equal to cos of theta. Tell me what is the cos theta? Cos theta means this divided by that. VR divided by V. What is the VR? I into R. What is the V? I into Z, complete Z. So what is the cos theta? That is the power factor is equal to R by Z. That is the magnitude. This is the power factor. R by Z. This is called what? Power factor. Remember, directly you can find if you have the magnitude of Z, if you have the magnitude of R, then directly you can find the power factor here. So this is the phasor diagram where VL leads the I by 90 degree, VR and I are in the same phase. Resultant V or applied V is leads the I by theta degree. Okay. Any doubt up to this point? KVL is clear. So always remember phasor sum. You have to apply the phasor sum. In an inductive circuit, okay, and V and R in same phase, you can write, or directly you can also write like this. Directly you can write impedance R plus j omega L, or from this you will get the idea. What is the V? KVL I into Z, I into R plus j omega L, V is equal to IR plus what? J omega L I. V, it is nothing but VR plus JVL. JVL. Okay. And that's why the magnitude of V is given by root over VR square plus VL square. And VL leads the I by 90 degree and VR and I are in same phase. So from that you can also say. Yes, yes. Okay. So that is the case. So you can directly write the Z, or otherwise that is the case. VL leads I by 90 degree and VR and I are in same phase. From that you will again get the idea. Then that is the phase, guys. Remember, in that case, what is the power factor? Power factor is cos theta, right? And what is the cos theta? This divided by that. Sin theta is VL divided by V. What is the cos theta? VR divided by V. And what is the V? What is the V? I into Z. What is the V? I into Z. So this is the tan theta. So you can write theta is equal to tan inverse of VL by VR. I can write theta is equal to tan inverse of, what is the VL? I into omega L. And what is this? I into R. And that's why theta will become tan inverse of omega L by R. Is it clear? Not is clear? Tan inverse of omega L by R. Because VR we can written as what? IR, and VL we can write as a I by omega L. I into omega L. Magnitude of impedance of the inductor. Is it clear now? I cancel ZL by R. And then power factor is cos theta. So we can write VR by V. So why a VR? What is the VR? IR. What is the V? IZ. This is the magnitude. I cancel R by Z. Finished. So So this is about what inductive circuit. This is the power factor or what theta or RL circuit. What is the phasor? Current leads the voltage, resultant, and so on. Similarly guys, RC circuit is important. So just I am giving you the idea about the RC circuit. This is C. This is R. Let we have applied the voltage V. Let this is I. So impedance because of C, it is given by minus J by omega C. And that will remain R. So you can write what is the overall impedance? R minus J by omega C. R minus J by omega C. Impedance. What is the V? You can write the V is equal to I into R minus J by omega C. So that is the IR minus J I by omega C. This is a voltage across resistor and that is the voltage across the capacitor, guys. So you can write the VR plus VC. But this time what is the VC? Negative. What is the VC? Negative. So VC minus J means what? Minus 90 degree. Because VC is equal to minus J I by omega C. So you can write I by omega C. It is the magnitude of VC and what is the angle? Minus 90 degree. Means VC lags I by 90 degree. The voltage across the capacitor lagging the current by 90 degree. And what about the VR? VR is nothing but IR. VR is nothing but IR. So they are in same phase. VR and I are in same phase. Remember, VC lags the I by 90 degree and we are in same phase. So first of all find the impedance, then find the V, then that is the value, guys. IR minus A by 1 by omega C. This is the VR and VC. This is called phasor sum. So we can write it like that. Okay, but that is the value is negative. Then now this is a value negative. Phasor diagram means let this is the current I. So what about the VR? VR will be in the same phase. So this is the VR. What about the VC? VC lags the I by what? 90 degree. This is the VC. So where is the resultant V? Resultant V is this one. This is the applied V or resultant V. So this is the VC, this is the VC. And that is the theta, guys. Negative angle. In a clockwise direction, it is negative. Current leads the voltage by theta degree. Current leads voltage by theta. Now, what is the magnitude of V? You can find root over VR square plus VC square, right? So this is the case. Then guys, what is the theta? You can find tan theta is equal to, this is the base, VR is the base and this is the height upon base. Tan inverse of height, what is the height? VC upon VR. So you can write 10 in, remember this is, you can write 10 inverse. What is the VC? Voltage across the capacitor, I by omega C. I am just writing the magnitude. And what is the VR? IR. That's why it will become 10 inverse of, what is the VC? I into 1 by omega C. What is this? IR. I cancel, it will become 10 inverse of 1 by omega RC. This is the theta. Lagging, angle is lagging. We are getting the magnitude of angle. Sorry, this is the leading, because current leads the voltage by theta, and that's why it is a leading angle, leading power factor we are going to get. In a capacitive circuit, we are getting the leading power factor. Watch it. This is the equation. If you have any doubt, you can write the comments. 2, 3, 4. This is the fifth one. VR and I are in phase. This is the conclusion. VC lags the I by 90 degrees. Seven, 8. And this is the angle 11th. 10 inverse of 1 by omega R C. Okay, if you again you want the power factor cos theta, then it will become VR by V. VR by V. That is the same, R by Z. R by Z, guys. Does anyone want the power factor cos theta? What is the cos theta? VR by V. Then it will become VR means IR, V means IZ. This is the magnitude only. So you will get the cos theta is equal to R by mod of Z. Okay, this is the power factor. Mod of Z, power factor. So I think we have solved one question on power calculation with RC circuit, power calculation with RL circuit, phasor diagram of RC circuit, phasor diagram of RL circuit. In one case it is leading, one case it is lagging. If the I leads the voltage, that is called leading power factor. If I lags the voltage, that is called lagging power factor. Okay, so we are taking I on a x-axis because I in a series I will remain same. This is the I. Voltage VR and I are in the same phase. VC will lags the I by 90 degree. This is the 90 degree. And in case of inductor, it will leads the voltage by 90 degree. So please get the command over that. In resonance circuit, in series resonance, in parallel resonance, again we will draw that. Series resonance means what? R, L, C are in series. Parallel resonance means what? R, L and C are in parallel. So we will draw what? Phasor diagram for RLC circuit in series or RLC circuit in parallel. Okay. So how to draw the, first of all practice it. Now you can understand, guys, if KCL or any doubt, first of all tell me. In the first slide, any doubt? co-representation है just what I am writing now. What is the JVC? What is the I have put there? What is the JVC? Check na. In equation number 5, what I have written? Minus. So minus J I omega C. So that's why what is the VC will become negative. No problem. Just suppose it is written like that. So I am just comparing the equation number 3 and 4. And in equation number 5, what I have written. Are you getting my point? But remember that it will lag the volt current by 90 degree. Suppose I am writing the negative here, then VC will become I by omega C. VC will become I by omega C, no problem. There is no contradiction between equation number 3, 4 and 5. Okay. ओके तो डिपेंड करता है, बस आपको क्वेश्चन में प्रैक्टिस करना है मोर एंड मोर. पॉजिटिव नेगेटिव ऑटोमेटिकली यू विल गेट द कमांड. Now, so this type of questions we have to solve. Then same try to understand, just we are applying a nodal analysis, mesh analysis, similar KCL, KVL, nodal, mesh, right? We are using all this method, KCL, KVL, nodal, mesh, star delta conversion or delta to star. Same logic we are going to use, but here we have to convert the inductor and capacitor in star to delta. And remember, always we have to use what? Phasor sum. So you can, what is the procedure? If the diagram is given in time domain, first of all convert it into what? Frequency domain. Frequency domain means if the L is given, if the R is given, R will remain R. If the L is given, it should be replaced by J omega L. C is given, it should be replaced by minus J by omega C. If the voltage is given in time domain, convert it into frequency domain. In previous class already I have given how we can convert in frequency domain. It is written like that, 5 angle of 45 degree. And current in phasor form, for example, it is given as 3 angle of minus 35 degree. Yes, you can write. So find the omega from time domain, convert the L and C and so on. If the diagram it is given in terms of J and so on, it is already in time domain. Simply you have to apply what? KCL and KVL, and you have to solve the questions, nodal equations and so on. But calculation is very lengthy, but actually in exam they are not giving so much calculation. Just I am giving you the one assignment, try to solve with hints how we can solve. Same logic, na, everything is same, mesh analysis, nodal analysis. For example, find Ix in the circuit of figure using what? Nodal analysis. First of all, tell me guys, this diagram is in a frequency domain or time domain? Tell me, this diagram is in a frequency domain or time domain? Watch this signal. This is in what? Time domain. This is Vt. What is the peak value? 20. Cos of 4t. So what is the omega? 4 radian per second. So this is, if suppose you are taking the cos as a reference cos, you can convert this voltage source as a 20 angle of 0 degree. If you want to convert it from time domain to frequency domain, this is the 20 angle of 0 degree. Now, what is the capacitor? 0.1 farad. In a frequency domain, it will become minus j by omega c. Minus j by, what is the omega? 4 into 0.1. That is the 10 by 4. So that capacitor is converted into, what is the impedance because of the capacitor? It will become minus j 2.5 ohm. You can check. 10 divided by 4, 2.5 ohm. 2.5 ohm. Then, what is the 1 Henry? 1 Henry, this is ZL1, J omega L1. This is the L1. This is L2. This is L1. And that this is L2. Then it will become J4 ohm. Because L1 is 1, J4 ohm. Similarly, what is the L2? 0.5 Henry. ZL2, J omega L2. It will become J, what is the omega? 4. And what is this? 0.5. 0.5. So 4 into 0.5, 2 ohm. J2 ohm. Now you have the value. The dependent source, that is the 2Ix. This is Ix is represented in caps. Caps, it will become converted into phasor and it will become 20 angle of 0 degree. Now you can write, you can convert the particular diagram in a frequency domain. Then the diagram will remain same, but this inductor, right, this capacitor, this battery, all are replaced by, this will become 20 angle of 0 degree, that is in phasor. What is the value of the capacitor? Minus j 2.5. What is the first inductor? J 4 ohm. And that is the second inductor, J 2 ohm. This is, you have to represent in caps. And that will become Ix. This is the phasor. Okay, now you have to find the value of the Ix. Then let this voltage is V1, this voltage is V2. Find the nodal voltage. Simple, apply the nodal analysis. I have given you the idea about the nodal analysis in previous lecture. So V1 minus 20 angle of 0 upon 10 plus V1 minus 0, this is the reference, upon minus J 2.5 plus V1 minus V2, V1 minus V2 upon J4, right, is equal to what? 0. Same to same. You can V1 by 10, you can write what? 0.1, and that is become what? It is when J is multiplied in above, it will become negative, and that is 1 divided by 2.5, and that is 1 divided by 4 you can get. And now this is the first equation. You have to arrange it, find the imaginary part and real part, and then guys, what are the coefficient of V1 and what are the coefficient of V2? You have to find, right? Then from this second equation, just I am giving you the hint. Tomorrow we will solve. Second, write down the KCL. What is the incoming current? 2Ix. And what is the Ix? Remember, V1 divided by minus J 2.5. So you have to replace it. What is the incoming current? This. V2 by J2. This is the outgoing current V2 by J2 plus V2 minus V1 by J4. You can also take the J4 as a LCM also. You can solve it, no problem. But remember Ix, what is the Ix? V1 upon minus J2.5 you have to replace. You have the two equations and two unknowns, and you have to find the V1 because you have to find the Ix. So from the two equation, two unknowns, you can find the Ix, and that is the answer. That is the answer for that particular question, guys. But remember, if you are getting, just I am giving you the, first of all, try to solve. This is the first equation, and that is the second equation. Suppose you are going to get the answer in this term. For example, you are getting the I is equal to A angle of theta. A angle of theta. A is the amplitude and theta is the angle. Then remember what is the reference cos and what is the omega 4. So answer will become, in time domain it will become A cos of 4t, omega is 4t plus theta. That will be the answer in time domain, and this is in a frequency domain. So first of all, get the value of Ix in time domain, frequency domain, then you can convert it into time domain, and that will be the answer. So solve one question, you will get the idea that same nodal equation, same type of KCL and KVL, but in a frequency domain, not in time domain. So you have to convert the diagram first of all in what? Frequency domain. Then write down and take care of what? This imaginary term and real part, proper multiplication, division and calculation. It is your part, and try to solve first equation and second equation and get the value of Ix. Get the value of Ix, that is nothing but V1 upon minus J2.5. Okay. So this is the assignment for you. So it will take around 10 minutes. You can solve it. So this is the question from standard textbook. Then tomorrow we will learn about what? Thevenin's theorem, Norton's theorem, superposition theorem, steady state, maximum average power transfer theorem. Okay. So all the theorems. So basic idea till now. Then Thevenin's, Norton's, superposition, maximum average power transfer theorem for steady state analysis of sinusoidal signal. So what about your journey up to this point? It is, I think, what, 13th or 14th class. Okay. So because it is a network, and that's why I want you have to get the command over what? All these topics. Extraordinary command. Then transient will become easy for you. Two-port network will become easy for you. And other topics will also become easy for you. Sir, equation 2 समझ नहीं आई. Which equation? Okay. What is the incoming current? We are writing the KCL at V2. KCL at V2. So what is the incoming current? Tell me. 2Ix. What is the outgoing current? V2 minus 0 by J2. So V2 by J2, it is the incoming, it is the outgoing V2 by J2. What is the outgoing? V2 minus V1 by J4. So V2 minus V1 by J4. Now here Ix. What is the Ix? Ix is equal to V1 upon what? Minus J2.5. So that is, I have replaced the Ix by what? V1 upon minus J2.5. And that's why this equation. Now this J and this J cancel out. All the J's are cancel out. Then it will become what? Very, very easy to solve. Yes or no? ना? तो आप और इसको easy कर सकते हो. This will become 2 by, this is J cancel. So it will become minus 2 divided by 2.5 V1 is equal to V2 by 2 plus V2 minus V1 by 4. From this equation, find the V2 in terms of what? V1. I am giving you the shortcut. Get the V2 in terms of what? V1. It is very easy. Shift the V1 on one side, V2 on other side, and get the V2 in terms of V1. And put the V2 in terms of V1 here. And get the value of the V1. Why? Because Ix is required, V1 divided by that. Finished. Okay. Tomorrow we will solve. Then tomorrow we will get the idea about the Thevenin's, Norton's, superposition and so on. What are the limitations? And we will solve some, this week we will solve some previous year questions also, so that you will get the idea that which are very easy questions on this topic. If you are getting this much command over this topic, you can solve any type of question from steady state analysis of sinusoidal signal. Okay, then thank you very much for attending the session. Have a nice day. Enjoy the journey of preparation, guys. Thank you.